So, Ohm's law, what did the V stand for? Voltage. What did the I stand for? This is the trickier letter to remember because, yeah, why don't we use a C for current? Because believe it or not, the letter C was already taken for other stuff. And not all physics was done by English-speaking people. So I is current. What does the R stand for? So it stands for resistance. Yeah, that's a good call. Let's, Halia, on your suggestion, underneath this, let's write the units for each one. What do I measure volts in? Voltage in, conveniently volts. That one works well. Capital V. What do I measure current in? Amps, capital A. What do I measure resistance in? Ohms. We would like to use it. No, we won't want to use an O because the letter O looks like the number 0. If you wrote that, 5 ohms, what would all of you think that was? 50. Yeah, so we're clever. We thought of that. And so we use the Greek letter O. It's the little omega sign right there. And you can get out your formula sheet. Okay. So stuff we should be able to handle now. I was introducing you last day, Marco, to this DFIC approach. In fact, what I usually do is I make these questions worth 2 marks. And I will give you, well, how many little steps do I have here? For 2 marks, what would make sense for each step? I will give you a half mark just for listing your data. In other words, even if you don't know how to do the question, if you can write down what they're asking you to find and what they gave you, I will give you a half mark. So here's the question. What is A asking me to find? Now, these are technically word problems, but physics word problems are way easier than math word problems because you're not going like, let X be the number or anything stupid like that. You can figure out pretty easily what they're asking you to find. Mention, what are they asking me to find in A? It's in front of you. Sorry, what? First thing I write down then is I write down V equals question mark. Do that. Why do I write that down? First of all, you do need to know what they're asking you to find, but I've learned over the years just by writing something down, it gets the mental muscles flowing. I do far better by not staring at a blank piece of paper. I'm less nervous. Now I'm going to go back and I'm going to read the question looking for numbers, but more importantly, or just as importantly, looking for units. I see a 12 mentioned. What's that 12? How do you know? Okay, and even if the word resistance hadn't been there, I could still figure out, it's got to be resistance. That's why I like memorizing the units. It's less reading, in all honesty. So R equals 12. You can put the ohms next to there if you want to. I have to be honest, I tend to, when I'm listing data, get a little sloppy in that I do all my unit checking ahead of time, and so if I write the number down, I know the units are correct, but you can put the units there. Then I also see an 8. What's that mentioned? Then we go to our yellow sheet. There's an equation that has a V, an I, and an R in it, and there's one of them that has the V by itself. Can you read it to me, please? Yeah, you. I would give you a half mark if I saw that. You know what? Can I be fussy? Can I go 8 times 12 just so that the I and the R match the same location so that I don't get confused later on? And 8 times 12 is 96? Yes? 96 what? Units? Volts, because we found a voltage. Okay? I will be fussy if you forget units. I'll take a half mark off. So this is one test. Before you hand it in, you go back, and for any written question, do a unit check. Okay? So here's our question. If a standard house outlet can apply 120 volts, and that's what comes out of your standard house outlets, could this motor run from a standard outlet, or would you need a special plug? Yeah. You're fine. There are some where you cannot. You'll notice if you ever pull certain appliances away from the wall, they have a funky plug because they need more than 120 volts. They need 240 volts. So 2 120 volt plugs have been spliced together by the electrician. And it's this really funky big round or orange plug.
Please excuse the interruption. As many of you know.
Next page. A blow dryer, this is one question we want to know. We're more interested in how many amps an appliance needs because that's what's going to blow your breakers. A blow dryer has a resistance of 13 ohms. If it's plugged into a 120 volt outlet, okay. Jimmy, what's A asking me to find?
Whatchamacallit?
I don't know. That's what I'm asking you to tell me.
Resistance?
Can you read it to me out loud?
I have no idea. A blow dryer has a resistance.
No, just read me part A.
Oh, how many amps of current?
What's it asking me to find?
Current.
Yeah, it's meant to be Captain Obvious when you know where to look. So let's write down I equals question mark. Jimmy, what's that 13? And by the way, what I do for most physics questions is I just look for numbers, and you'll also learn later on there's also physics words like at rest or comes to a stop, but mostly we're just looking for numbers. What's that 13? Look at the units next to it.
Resistance.
Has to be. What's that 120?
Voltage.
Has to be. Jimmy, there is an equation that has a V and an I and an R in it, but since we're trying to find the I from your yellow sheet, can you read me the one that has the letter I by itself, please? So there's an equation, it's got a V, and in the boxes you're looking, right?
Yeah.
So read me the one, it's got a V and an R and an I, but read me the one that has an I by itself. Marco. Sorry, say it again. V over R. I missed the over because somebody moved a chair. Yeah. You don't need to memorize these. You can if you really want to. You know what? The only reason you should memorize them is if you get sick of looking them up and you want to memorize them. That's the only reason you should ever memorize anything. It should be a shortcut, but you don't need to. What was the voltage, Jimmy?
What?
What was the voltage? What was the resistance?
15.
What do you get? Ooh, dividing by 13. That's a yucky one because it's prime. What do you get? Sorry?
9.
Even?
What?
No.
9.307.
Oh, my calculator can't do that.
It should be able to do decimals and stuff. I'll muck around with yours later. What do you get? 9 point. Let's go to 2. Let's say when in doubt, if it doesn't work out evenly, we'll go to 2 decimal places. Going much past that is overkill. Is 2.3 rounded off properly, or what's next to the 3? Okay, 9.23. 9.23, Jimmy, what? Units for current? Jimmy? Yeah. Okay. Now, I combined everything in one line there. But you can see I did all 4 steps. I listed my data, I found a formula, insert the numbers, correct. And usually I tend to do that because I'd like to save paper. So I do this all in one line. Okay, here's the problem. Most appliances do not tell you their voltage or their resistance or their current. If you flip over a standard appliance, and you can do this at home, or you look on the front of it if it's a bigger appliance, what they'll tell you is their power usage. Measured in, power is measured in watt? Watts power measured in? No, there you go. Okay. Why do we give you the power? Power is the rate at which electrical energy is transformed. Power is how fast this device uses up energy. Transformed into other types of energy, and the most common one usually is heat, but not always. I'm not going to test you on this next bit. This is purely to help you understand how wattage works. I've given you a bunch of appliances here, and then I've scrambled out a bunch of appliance wattage uses here. I'm going to give you some hints. The more heat an appliance has to move around, the higher its wattage. Looking at these appliances, which of these do you think moves the most heat around? And I'm going to give you a hint. If you pull it off of the wall, you'll see it actually has a special plug. It doesn't plug into a regular outlet. Clothes dryer, by far. What's the highest wattage on the right-hand side that I gave you as a list? So the clothes dryer uses just shy of 5,000 watts. You can cross out the 4,800. Of the remaining appliances, which one do you think moves the most heat around?
Hot water heater.
Cleo. What?
Hot water heater.
If you have an electric hot water heater. Now, some people have a gas hot water heater. Water has a tremendous ability to absorb a lot of heat. In physics, we say it has a very high specific heat capacity. It's why we use it to put out fires, among other things. It's pretty good at that. So what's the next highest wattage we have available? Hot water heaters are usually around 3,000 watts-ish. Cross out the 3,200. Now we're going to reverse this. Which of the appliances uses the least amount of heat? And I'll give you a hint. You can run it off of a small battery for probably about a year or two. Yeah, like the wall clocks behind me on the wall behind me. I replace that battery every couple of years. What's the smallest wattage left? Okay, clock uses almost no power. They're very efficient. That's why you can run them off of a small battery, or even more specific, if you look at your wristwatches, that's an even smaller battery with less electrons to share, but those can run for 3 or 4 years sometimes. Yes? Okay. One of these I know, because I've changed light bulbs. What's the wattage on a standard light bulb? Have you ever replaced a bulb? Yeah, most of them are 60-watt bulbs. 100-watt bulbs are a little bright. Most of the ones in your house are 60-watt bulbs. So next to light bulb average, I'll do that. And that leaves us with 3 more. Does anybody know what a microwave oven, a large microwave oven, has as its wattage? Pardon me? 1,200. How many of you have microwaved something? How many of you have read the instructions? This is why it always says microwave oven times may. It always says vary, because microwaves go anywhere, like the smaller ones are about 800, 900 watts. The bigger ones are about 1,200 watts. That's actually a significant difference. That's about a 30% difference, which means there's a fairly big range in your times. So to cover themselves legally, the instructions always will tell you microwave oven times may vary. A large microwave, yeah, it's about 1,200 watts or 1.2 kilowatts. We got 2 left. Of the 2 remaining, which one do you think moves around the least amount of heat? Kitchen fan. Because the computer has a fan inside of it, as a matter of fact. The computer would definitely have more than the kitchen fan, because I know computers have fans of their own, as well as having to run the monitor and the motherboard and all that stuff. So kitchen fan is around 150 watts-ish. Computer is about 800 watts-ish. And you can replace, if you want to in your mind, Brianna, the notion of watts with using power quickly, using energy quickly. Which ones are more expensive to run? Your dryer. Which one is really cheap to run? It's why it's fairly energy efficient to cool a kitchen with a kitchen fan. A kitchen fan isn't using that much energy. Using some, but it's more efficient to do that than, say, run an air conditioner. Air conditioners are almost always fairly high wattage because they're moving a lot of heat around, only they're moving heat from inside your building to outside your building, but they are moving a lot of heat around. So high wattage, you're moving a lot of heat around. Low wattage, you're not. By the way, that means your smartphones are fairly low wattage, although you notice they do get warm. And they do even get warmer if you're doing a heavy computation video game or something like that. You will notice, you may, if you really pay attention, be noticing, oh, I'm feeling my phone's getting a little warmer. So, an appliance that has a higher power rating uses more energy or less energy? More. In 1 minute, than an appliance with a lower power rating. And this is going to give us, oh yeah, turn the page. This is going to give us yet another equation. Do you need to memorize this equation? Everybody say no. No, they're going to be on your sheet. What you need to do is know where they are, which is why I keep telling you, get your yellow sheet out and look inside the boxes. So power is the rate at which energy is used up. As an equation, we write this. Power is energy divided by time. We measure energy in joules. We measure time in seconds. So the units for power is technically a joule per second, except we use this so often, we've given it a special name. Power is measured in what? Symbol capital W. Named after a scientist whose last name was Watt, James Watt, who improved the steam engine. In Physics 12, I always go on a little rant. To me, James Watt is really overrated and shouldn't have a unit named after him. What he was a very good salesman. But that's a whole other Physics 12 rant. Take Physics 12 if you want the rest of it. In 1840, a scientist named James Joule, after whom we've named the unit for energy, found how to calculate electrical power. So power in general is the amount of energy divided by the time. Electrical power can be calculated by the voltage times the current. If you know how many volts an appliance needs and you know the current flowing through it, that's how many watts of power it's using. Where P is electrical power in watts, V is the voltage drop in volts, and I is the current flowing through the resistor or the load. The textbook calls them loads. I was always taught to call them resistors, and so I'll flip-flop between the two. It's an appliance or an iPod or whatever electric device we're running. This equation is called Joules' law. How many letters does this equation have? How many variables does this equation have? Careful, count carefully. How many variables does this equation have grand total? 3. It's actually 3 equations in one, because you can also write it as I equals P over V and V equals P over I. Did I give you those on your yellow sheet? I think.
Yes.
Yeah. We can also write Joules' law a couple of other ways. I can write this as P equals, instead of writing V, I can write I times R and then times I. Because V is I times R. Except I wouldn't write I would write I times R. Except I wouldn't write I times I. You've learned there's a lovely shortcut for writing I times I. How do you write that in math? Yeah. So another equation, did I give this to you on your yellow sheet? Is I squared R? I did, okay. When would I use that? Oh, if they asked how much power, but they gave me the current and the resistance and not the voltage. Oh, I'll use that one. And then there's another one, power equals V squared over R. Did I give you that one on your formula sheet? You know why? It's redundant. What does redundant mean? You can survive just fine without it. Usually, like if I know V and I know R, can't I figure out I, and then I just use V times I? In fact, even this one is redundant as well. If I know I and I know R, I know V because V equals I times R, and then I can use V times I. So these are more, they're handy if you have them, shortcuts, but they save you 2 lines or 1 line. Let's apply some of this. So here are our equations. I wrote double check on your formula sheet. Can you find all of the above equations? They should be in a box there, yes? So you know where they are? All right, let's apply this. Example A, I like this question, I like this question, I like this question. I'm going to ask you questions to figure out how your household wiring works and how much power you're using. Find the current in your house wires if you plug in a 1400 watt hair dryer. So here is a picture of a circuit. We have a voltage source. How big is our voltage source? 120. What does AC stand for? Alternating current, which is what comes out of your plug outlets. I'm going to be teaching you all about direct current because that's a little easier. Most of what I teach you, though, if you decide to get into electronics, can also be applied to alternating current. Okay. And in the standard house circuit, what you usually have is the plug has 2 outlets, and then it runs back to the voltage source. Okay? What does this question want us to find, Julia? Find the? Let's use DFIC. I'm going to write down I equals question mark. Let's look for numbers. I see a 1,400. What's that? Look at the units next to it. So what is 1,400 a measure of? But what do I measure in watts? I want the noun. Oh, power. P is that. So how we got that, Julia? I need one more thing. Oh, what's that 120? Julia, I'm looking for an equation that has a P, a V, and an I, and since I want to find I, read me the one that has the I by itself from your yellow sheet. Look on your yellow sheet. Get your eyes used to looking. By the way, the reason I'm doing that is your eyes will actually develop the habit when you think of the equation, glancing in the right place, the same way they started to do for the periodic table. You notice by the end of it, if you would think of an element, even though you didn't know where it was, your eyes would often glance in the right area. Your brain had subconsciously remembered that. So we're going to do the same thing here. What's the equation, Julia, my joy? Julia, my joy?
I equals P over V.
Good. So there's the D, list your data. There's the F, find a formula. Now we insert 1,400 divided by 120. How many amps does this hairdryer need to run? Yeah. 0.6 or 0.7? We're going to round off properly. Is it 6 repeating? So let's go 11.67. I said to 2 decimal places when in doubt, and amps. So almost every one of your standard household circuits, with a couple of exceptions, can only handle a maximum of 15 amps. So Julia, here's the question. Could you run 2 hair dryers from this plug? Jordana, why are you shaking your head? How many amps would I need if I wanted to run 2 hair dryers? 23 point something. This is why you blow a breaker. You blow a breaker because you've asked that circuit to give you more than 15 amps. That's a safety margin that's built in, because I've told you current is what causes damage. In wires, current is what heats them up to red hot burning and starts house fires. So we have these built in. We can let the wires get a little bit hot, but once they're going to get past that, we have safety measures built in. You'll trip a breaker. And so many of you may have tripped a breaker and then been, I don't use this word very often, dumb enough to try and replug the same device in and been shocked. Why did the breaker go again? Because you're still asking that whatever you're trying to plug in is requiring a total of more than 15 amps, because there's something else that's drawing current as well. It's also why you may notice, oh, the plug was just fine. It was running the blender, but when I turned on the microwave, that's what blew the breaker, because now adding both of those currents up was more than 15 amps. Does that make sense? So, no. What do you think would happen? You would blow, you know what? We call it trip a breaker. We used to blow fuses, trip a breaker. In the olden days, before we came up with these breaker systems, which are just resettable, they're a little switch, if you're in an older house, you may notice you have fuses, and the fuses were little thin pieces of metal, and they were designed so that if they got hot beyond a certain point, they would melt, and now the connection would break, and you'd have to physically actually replace the entire fuse. So that's still used in cars, boats, and RVs. Those don't have breakers. Those have fuses, because there often you have power running when people aren't there. You're recharging the batteries on your boat and you walk away. So you have a system that is a little more foolproof. Does that make sense? There you go. If the hairdryer runs for 2 minutes, how many joules of energy will it use? Petco, what's this question asking me to find? Of? It's asking me to find energy. Joules are the unit. It's asking me to find energy. Energy is E. Question mark. Now, I still know some stuff. What was the power, Petco? Okay. What was the voltage? I have the current. I'll use it if I need to. But what else has this question given me? What's that 2? What is that 2? Time. T equals 2. What did you say? 2 what? In physics, we don't do any math with minutes or hours. We have to convert things to seconds. Now, the nice thing is probably you've memorized this just by growing up. How many seconds are in a minute? 60. So did I put that on your formula sheet? I don't think I would have. I think that one I might have assumed you got that. How many minutes are in an hour? 60. How many hours are in a day? I think it's reasonable for me to assume you've picked up on those ones. So I usually don't give the kids that piece of information. So how do I change minutes to seconds? I do something with the 60. What do I do with it? Times by 60. So do that, or you can do it in your head or on a calculator. 2 minutes is how many seconds? Okay. Petco. I'm looking for an equation that has an E by itself and then has some combination of power, voltage, time, and current if I need it. Is there one? Which one? Read it to me, please. Can you read me the E equals? Power times time. Okay. That looks... Do I know power? Do I know time? Okay. So how many joules of energy is this going to use? You get a big answer. It's because 1 joule is not a lot of energy. Also because hair dryers use a lot of power. They're moving a lot of heat around. 168,000? 168,000 joules of energy. Mostly heat. Although, is there, when you turn on a hairdryer, some sound? Sound is also a form of energy, but it's mostly heat. Let's have a house party in the backyard. Tensei is having a house party. He's got one extension cord. He wants to do an outdoor backyard party. He's plugged it into a 120 volt wall outlet. He wants to have a backyard barbecue. He's going to invite his friends, and he wants to run the following appliances. A 420 watt blender. He looked at the wattage on the bottom. A 1200 watt outdoor projector. A 900 watt coffee maker, and a 660 watt stereo. Let's complete the following chart. The voltage source is 120 volts. So power required, blender was 420. Projector was 1200. Coffee maker was 900. Stereo was 660. Okay. All of these are being plugged into a 120 volt source. There's 120 volts flowing through them. So how many amps is the blender going to require? Okay. I want to find the current. I know the power and the voltage. Can somebody give me the equation that has the I by itself and has power and voltage? Let's just write it down once. And now let's just go to our calculator. So how many amps will the blender use? I guess it's going to be 420 divided by 120. I think I can do that in my head. It's going to be 42 over 12 divided by 6 divided by 6. It's going to be 7 over 3. Is it 2.66666? Double check me. No, 2.33333. How many amps? 3. Am I way off? Duick. 3.5 amps? Wow, that was way off, Duick. I can do projector in my head, 10 amps, yes? Double check me, but it is 10, is it not? 1200, on your calculator, right? 1200 divided by 120?
Yeah.
900 divided by 120, it's going to be 90 divided by 12. Divide by 3, divide by 3, it's going to be 30 divided by 4, 15 by 7.5? Double check me. Coffee maker, 7.5? Someone type this in. This is how we go. 70? No way is it 75 amps. That would fry your house every time you plug the coffee maker in. Your house would burn down. Have a cup of coffee, your last cup of coffee. 7.5, yeah? Got me worried for a second there. 660 divided by 120, that's going to be 66 divided by 12, divide by 3, divide by 3. It's going to be 22 over 4. It's going to be 11 over 2. 6.5? Double check me. 5.5. 5.5. Do it. Carry the 1. By the way, do I know the current? Everybody say yes? Yes? Do I know the voltage?
Yes.
Well, then I can find the resistance inside each appliance as well. You're going to hear me say this over and over, but I'll say it for the first time now. When we're analyzing circuits, there are 4 things: power, resistance, voltage, and current. If you know any 2, you can find all 4. If you know any 2, you can find all 4. Can you write me an equation that has the R by itself, please? V over I? So for all of these then, if I want to find the resistance in the first one, 120 divided by 3.5, that has a resistance of 34.29 ohms. This one I can do in my head, 12 ohms. 120 divided by 10, that one I can do in my head. 120 divided by 7.5. So now you can start to see how we design these ahead of time. 16 ohms. 120 divided by 5.5. 21.82 ohms. So Tensei, these are his plans. But your standard household outlet can only handle 15 amps. Can he run all of these from one outlet? Oh, got the all caps still on. Nope. Hey, which appliances or which combinations of appliances can he run successfully? Hang on, we'll pause for 1 second.
But if we could have grade 9 students.
What combinations of appliances can he run successfully? Stereo and coffee maker. Any other combinations? Can he run 3? Is there any way he can run 3? Okay. So what's the workaround? He's going to have to get a second extension cord and run it to a completely different outlet, and that outlet has to be on a different circuit. You may find, if you're in a multi-story house, that an outlet on floor 1 and the outlet right above it in the second floor are actually all part of the same circuit. So I know where I live, if I plug in there's a plug in my kitchen which I would love to use. It's where I would put my microwave, but the people upstairs must have something pretty heavy duty plugged into that plug, because every time I plugged in my microwave, it blew the breaker. And so I just don't, because I don't want to be an idiot or whatever, and I can put my microwave somewhere else. But clearly we're on the same circuit vertically. So Tensei would have to find out ahead of time, or he would plug it in and the breaker would blow and he would go, rats, I need to try a different outlet. Okay. Is that kind of explaining to you, those of you that said you've blown a breaker, what's going on? Okay. It's not mystery or witchcraft. We can figure it out. So a typical blender uses 300 watts. It's plugged into a 120 volt outlet. Find, Brianna, what does A want me to find? Current. What does B want me to find? Are we finding 2 things? Say yes. You know what? Here's my level of organization. Draw a line down the middle of the page. On your own, use the DFIC approach. I'll do it up here. Let's see if we get the same thing. I'm just going to go. We want current. Oh, sorry. I forgot to list. I equals question mark. And this is what someone said, what's watts? This is why, Halia, I said, it's worth memorizing what units go with what, because it cuts down on your memorization of everything else. And if I'm going to memorize something, I'm going to take the laziest possible way to do it, right? I'm going from memory. Let me know if I make a mistake. I can do this in my head. It's going to be 30 divided by 12 divided by 6 divided by 6. It's going to be 5 divided by 2. I'm doing the math in my head. Let me know if I'm wrong. Oh. Look up for a second. For part B, since you've already listed your data over here, you don't have to just relist it. If it's right on the same question, I'm fine with that. In fact, usually if it's on the same page, I'm fine with not relisting it. So I'm not going to write P equals 300 and V equals 120. I already did that. I'm not going to make you do it twice. That's silly. $120 divided by 2.5, that's going to be the same as 1,200 divided by 25, which is going to be 48. Double check me. Am I right? Check my math. I'm doing this all in my head. Is it 48? I can do math in my head, even when there's decimals. So you can imagine, Jordana, part of your test, and but this is also handy, but part of your test, I'll give you 4 or 5 of these in a row, and I'll say, hey, here's this and this, find the resistance. Here's this, this, and this, find the power, find the energy, using the equations. As long as you're medium organized, write down what they gave you with a question mark, list what they gave you. So write down what they're asking you to find with a question mark, list what they gave you. You got the equations, go to it. It's plug and chug. Is it 2.5 amps and 48 amps? How many got both of those okay? Ohms. Did I say amps? Ohms. Thank you. Okay. Let's do this one together. I see a part A. I see a part B. My head tech solution with a part A and a part B is to do that. Here's part A. Here's part B. Clothes dryer is rated at 4,800 watts. It draws 25 amps of current. Mr. Dueck, I thought you said household outlets can only handle 15 amps. If you ever pull your clothes dryer off from the wall to clean behind it, you'll see that's a special plug. Oh, there's one other appliance that has a special plug. What's the other appliance in your house that moves by far the most heat around? Not your hot water heater.
Dishwasher.
Not your dishwasher.
Oh, the stove.
Yeah, stove. Pull your stove off the wall, you'll see, and there are these massive round, they're about yay big, they're a 240 watt outlet. They look really funky because instead of having 3 prongs, they're like little curvy things, so you can only plug them in a certain way. The third place you might have one is if you have an electric car, then they'll often put one in your garage because it'll recharge the car twice as fast. So my friend just bought a Chevy Bolt, so he had one put in his garage as well. Those are about the only 3 places you'll see them in a standard house. What do they want me to find? Oh, V. Is that right?
Yeah. Yep.
Okay. Oh. That's wrong. No, is that right? Yeah, I guess. Yeah. I thought it'd be a higher resistance than that, but I guess not. So, part C, can a dryer run from a standard 120 volt outlet? No. It's why if you're ever building a house, you have to decide well ahead of time, where's the dryer going to go? Because the electrician's got to wire that room specially. Where's the kitchen and the stove going to go? They have to wire that outlet specially. So, no. This is fairly accurate. I looked up a PS4 wattage. So PS4s take about 140 watts while playing video games.
Do you have a PS4 in the studio?
No, I had a PS3 for a while, but it eventually died. How much energy is used when playing a game for 8 hours? Quentin, what's this question asking me to find? Oh, what's the letter that we use for energy? E equals question mark? Okay. Quentin, what's that 140? Sorry? Yeah, what is it? Power. P equals 140. What's that 8? Why don't I like it? Okay, so I'm going to write T equals 8 hours. I always write the units down when they're the wrong units because those bug me. I've got to do a conversion. I need to change that to seconds. How do I change hours to seconds? I don't know. Wait a minute. How do I change hours to minutes? And how do I change minutes to seconds? Now, the shortcut, I think, is times by 3,600. Did I put that on your formula sheet somewhere? I did?
Yeah, that'd make more sense.
Yeah, you did.
Because times by 60, times by 60. If you're looking for a shortcut, it's that. But if you ever blank out or you don't have your formula sheet handy, I just figured out a way that knowing what you've already memorized, you can figure it out. What is 8 times 60 times 60? 28 what? Somebody read it out? 28,800 seconds. Quentin, what are they trying to find? No. Can you give me an equation for energy that has a P and a T in it and has the E by itself?
E equals P times T.
Okay, so the amount of energy we use is going to be 140 times 28,800. 140 times 28,800. You get 4,032,403,2 and then 3 zeros. 4,032 and then 3 zeros. 4,032,000 32,000 joules. I will ask, how many of you ever played video games for 8 hours straight? Okay? Using up 4 million joules in 8 hours, what you're really noticing is 1 joule is not very big. Your parents, and once you all move out of the house and start paying your own utilities, you will get electrical bills. Electrical bills don't charge you for power, they charge you for energy. Okay? You pay how much energy you used. You pay BC Hydro for energy. Now the problem is, if they charge you in joules, people would freak out because you would have bills that were saying you'd used 80 billion joules, and people don't like those big numbers. It's very intimidating. And so even though in physics we measure energy in joules, electric companies measure energy in kilowatt hours, not joules. Now, kilowatt hours sounds like it's power because it's got watts in it, but wait a minute, what's hours a measure of? See, it's watt time. Hey, it's watt time. Kilowatt hours is energy. So if you ever get an electrical bill, they'll give you the energy you used in kilowatt hours. And so one of the questions I am going to ask you to do on your test is to convert joules to kilowatt hours from your formula sheet. 1 kilowatt hour is what? A 3, a 6, and how many zeros? I already put the J there. Joules. So if we go back to the previous example, how many kilowatt hours were used by the PS4? 1.12. How do you figure it out? So this question is asking us to do a conversion. So if I want to change energy to kilowatt hours, do I take that joules and times it by 3, 6, and 5 zeros? Do I add 3, 6, and 5 zeros? Or do I divide? Conveniently, your favorite Science 9 teacher probably stuck that on the, is that on the top right corner of your yellow sheet? The conversion method? Yes? What do you do, Cleo?
Divide.
Okay, so let's write down in our notes. Now, in your homework, if you go straight to your calculator, I won't freak out. Let's write this in our notes so that when we're studying, we know what the heck we did. 4032,123 divided by 36,123,4,5. How many kilowatt hours of energy did you use? 1.12 even? And the abbreviation for kilowatt hours is lowercase k, kilo, watt, hours. I think the rate is slightly wrong. It's not 7 cents per kilowatt hour. I think it's 7.8 cents or something like that, but close enough. If BC Hydro...
Please pardon the interruption. Any grade 9 students?
Problem here. If BC Hydro charges 7 cents per kilowatt hour, how much does it cost to play the game for 8 hours? Let's figure out how much this costs. Did I put that on your yellow sheet?
Yes.
How do I figure out what would be a good abbreviation to use for cost? Dollar sign? Is that what I use, or did I use a C for cost? I wrote the word cost? So you know what? I agree. A dollar sign is a good abbreviation. How do I calculate the cost? What do I do according to your yellow sheet? Let's write this down. It's going to be kilowatt hours times rate. How many kilowatt hours? 1.12 times 0.07. This is a problem we have right now. What do you get? Do you get 0.078? Now, we're talking dollars and cents. So Marco, who's not foolish, looking at his phone right now, we're going to round off to the nearest penny. Here's the problem. How much did it cost you to pay the video game for 8 hours? 8 cents. We make electricity too cheap. Because to get you to turn things off or turn off the lights when you leave the room or shut the TV off or whatever, the economic argument is pretty weak to say to you, well, you'll save money. Yeah, you might on your electric bill by the end of the month, if you're really cautious, Marco, you might save $3. $3 isn't that much. Why do we tell you to turn off the lights? Why do we build appliances more energy efficient? It's for the environment, for the planet, because there's a limit to how much energy we can create. We're pretty good at creating it. Go ahead, Brianna. We're pretty good at creating it here in BC. We built hydroelectric dams, which actually aren't that green. They destroyed a lot of trees. They wrecked our rivers. They destroyed our salmon runs. But now that we've got them in place, it's a pretty good way to generate reasonably clean electricity. But we don't want to have to build new ones if we don't have to. You may have heard much in the news recently about the Site C Dam project in Peace River that they've been debating whether or not they need to build or not build, because there's always pros and cons. It would be much nicer if, you know what, shut things off when you're not using them, not for the money, for the planet. There's my little rant, but you can see, because I got to be honest, to try and tell you, oh, that 8 hours of video games, that cost us 8 cents. I think you'd laugh at your parents' face and you'd say, here's a dime, keep the change. Right? I mean, I gotta be honest, that's not much money. Even for high school students who don't work full-time. Certainly if you work full-time, whatever. Why do we turn things off? To save the planet. Is that okay? How far am I gonna get here? We've been talking a long time. I think we're going to go like this. We're going to pause here. Yes, says Celine.